Alright guys, this is a help video for the 11.4 worksheet ideal gas equation looking at number 3. So let's do number 3. Now again, I'm using my numbers. Yours will of course be different. Alright, let's see here. I'm going to pause this real quick and change the numbers to something a bit nicer. Okay, so you have 0.73325 moles of carbon dioxide gas. It has a temperature of 168.45 Kelvin and a volume of 80.4 liters. What is the pressure in the container? All right, at atmospheres pressure. All right, it's looking for atmospheres of pressure. So let's plug it into our equation. Here we go. All right, problem number 2. Skadoink. All right, so we are going to use the ideal gas equation. Remember, it can be written as PV over NT. That's a bad N. NT, all right, capital T, Gucci. All right, and that's equal to the gas constant. But this equation is annoying to do algebra with because we all hate solving for variables in the bottom of a fraction. So oftentimes teachers will give this to you pre-rearranged to look a little something like this. All right, the pressure of a gas times its volume is equal to its number of moles times the gas constant times T. I don't know why they did it in this order, but teachers call it the perv nerd equation, all right? Don't be a pervert, use perv nerd. We used to say that. I still say it. So let's get down to business, all right? So the pressure of a gas times its volume is equal to however many moles you have times the gas constant times the temperature. So let's plug in what we know, all right? In problem number 3, it says that I've got 0.73325 moles. So I'm going to replace moles with 0.73325. All right. I'm going to replace the temperature with, it says here, 168.45 Kelvin. All right. By the way, let me just pop in here and make sure that we're looking at the same thing. I want to make sure that you see where this is coming from. Okay, so there's the mole amount. There's the temperature. The volume is 80.4 liters. The volume is 80.4 liters. So I've got the volume. So 80.4 liters. Okay? And they want to know the pressure. So we're trying to find what the pressure is in atmospheres. That's important. It's important because we have to find the right gas constant to use, and the gas constant we use depends on what the pressure value is. So I go to my homework, I take a look, what is the gas constant for atmospheres? And it is 0.0821. Oh, is it? Yeah, okay, so I used atmospheres in both of these. Well, you know, it is what it is. All right, so we'll go back here. 0.08. Oh, I didn't leave enough space. I'm gonna fix this. I'm gonna fix this with the power of editing. Wish you could do this on your worksheets, right? There we go. Look at that. Look at that. Doing it live. Here we go. All right. There we go. So 0.0821. Okay, there we go. This is the gas constant for atmospheres of pressure. Okay, that's not always the gas constant. You got to look for whatever gas unit you are using because they each have a slightly different gas constant. All right, so here we go. We're solving for pressure, so let's divide both sides by the volume. All right, 80.4 liters. All right, cancels out over here. All right, 80.4 liters. So the pressure is equal to 0.73325 times 0.0821 times 168.45 divided by 80.4. Let's get that decimal in there real good for all you iPhone watchers. All right, so I'm going to just plug this into my calculator now. 0.73325 times 0.0821 times 168.45 divided by 80.4. All right. Drum roll, please. The pressure in atmospheres is, oh, it's not very high. All right. The pressure is equal to, make it green. The pressure is 0.126 atmospheres. Why did I do an AMT? Atmospheres, okay? Atmospheres. There we go. Or roughly 1/8 Earth pressure. This is like thinner than the air at the top of Mount Everest, all right? So let me put that into my worksheet. Here I go. Okay. 0.12, what was it again? Lord Gucci. 126 atmospheres. Now, why did this round? Why did this round? Here, I'm going to change this. I obviously got to do some formatting here. So 0.126 atmospheres. Very good. Okay, awesome. Well, that's a wrap. Here we go. Box it. Send it.